Good morning students. How are you all? I hope you all are fine. Okay children, last class we have learnt about properties of a complex number. Today we are going to learn conjugate of a complex number. Okay. Today what we are going to learn? Conjugate. Okay. The conjugate of a complex number x plus iy is x minus iy. The conjugate of a complex number x plus iy is x minus iy. Okay, suppose if one complex number is given means, how can we find conjugate means? See, consider one example, 3 plus 4i. 3 plus 4i is one complex number. How can we find conjugate? Just you replace plus I by minus I. Conjugators, just you have to change the imaginary part only. Don't change real part sign. Just you change the imaginary part sign. Plus here means you have to change it as minus. Just we replace plus I by minus I. That is conjugate. See here 3 plus 4i. What is the conjugate of this complex number? What is the imaginary part sign? Plus. Just you change it as minus. 3 minus 4i. Okay, now I'll ask one question. 4i minus 3 is given. What is the conjugate? 4i plus 3? No, it is wrong. Why it is wrong? Because complex number form is real part plus imaginary part. Now real part is minus 3 plus 4i. What I told, if you want to find conjugate means what you have to change? Just to change it, the imaginary part sign. Here plus sign, you have to change it as minus. Now here, what is this? Plus. So what is the conjugate? Minus 3 minus 4i. So this is the conjugate. Got it? See, first you have to look whether it is in the standard form or Cartesian form, x plus iy. Afterwards, you have to change the imaginary part sign. That is the conjugate idea. Okay. Now, the symbol of conjugate is Z bar. The symbol of a complex number. The complex conjugate of Z is denoted by Z bar. That is symbol of the conjugate is Z bar. Then x plus iy into x minus iy equal to x squared plus y squared. Now this is in the form of algebraic form, a plus b into a minus b. Generally a plus b into a minus b, a square minus b square. But here this is also in the form a plus b into a minus b, but here x square plus y square. Why? Because here plus into minus minus, I into I square value minus 1, so minus into minus plus. So just you remind this is formula, always one complex number and its conjugate and its product answer is a real number. That is real part square, x square plus imaginary part square. No need to worry about sign. Okay, x square plus y square. Got it? Next, properties of complex conjugate. See, all these properties given in your book. Just I am going to explain what is this. Okay. Now, first property, addition. Z1 plus Z2 to the whole bar. That is sum of the complex number and its conjugate is equal to Z1 bar plus Z2 bar. We can write here two conjugate sum. Okay. Z1 bar plus Z2 bar. Similarly, subtraction also. Z1 minus Z2 the whole bar is equal to Z1 bar minus Z2 bar. Okay, then product Z1 into Z2 the whole bar is equal to Z1 bar into Z2 bar. Then division form, Z1 by Z2 the whole bar is equal to Z1 bar by Z2 bar, and condition Z2 is not equal to 0. It is very important. The denominator complex number should not be equal to 0. So always it's some complex number. Z1 bar by Z2 bar. Suppose if it is 0 means anything by 0, infinity we cannot find. So Z1 by Z2 the whole bar is equal to Z1 bar by Z2 bar. Next, real of Z is always equal to Z plus Z bar by 2. Real of Z is equal to real Z plus and its conjugate divided by 2. And imaginary of Z is equal to Z minus Z bar by 2i. See, just you remind this as real means plus, imaginary means minus. Here 2 will come, here 2i will come. In imaginary of Z is 2i. So real of z equal to z plus z bar by 2. That is one complex number and conjugate divided by 2. Imaginary of z equal to one complex number minus and its conjugate divided by 2i. Okay. Next, seventh property. Z power n the whole bar is equal to z bar the whole power n, where n is an integer. See, one complex number to the power n, the whole conjugate is can be written as z bar the whole power n. We can interchange bar and n. Z bar the whole power n, where n is an integer. Next, eighth property. Z is real if and only if z equal to z bar. See, z is real if and only if z is equal to z bar. See, consider one example. When we say z is real means, if z equal to z bar means we can say that z is real. Suppose if we assume z equal to z bar means we can say z is a real number. See, z equal to 3. 3 is a real number. But what is z? Z is a complex number. But here I am writing 3. Is 3 is a complex number? Yes. Well, if we write 3 as 3 plus I0 means it is a complex number. Okay. Any number plus 0 is equal to same number, isn't it? So 3. What is the conjugate of 3? Minus 3? No. Why? Because it is a real number. Conjugate of real number is itself. So z bar also 3. So z equal to z bar means what is z? It is a real number. Okay. So this is the concept. So when z is real? If z bar equal to z bar. Sometimes we use this concept in properties. Okay, just you remind this. Then z is purely imaginary means if and only if z equal to minus z bar. See, z is purely imaginary if and only if z equal to minus z bar. Suppose if you assume z purely imaginary means what is true? Z equal to minus z bar. Suppose if z equal to minus z bar is true means what is true? Z is purely imaginary. Next, 10th one. Z bar the whole bar equal to z. See, one complex conjugate and its conjugate is a complex number, the same complex number. Suppose minus into minus plus no. Similarly here we cancel this 2 bar. So we get same z. Z bar the whole bar is equal to z. So just you remind all these properties. Okay. Next we are going to see exercise problem based on this properties. Okay. So first one. Write the following in Cartesian form. Cartesian form, general form or rectangular form or is x plus iy. Okay. Cartesian form, a rectangular form, a general form of a complex number is x plus iy, general form. See, we are going to write this as an x plus iy form. Okay. Now, the first problem is 3i bar plus 1 by 2 minus I. See, what is bar? What is this? Conjugate. Good. 3i bar plus 1 by 2 minus. So here there is no bar, just division form. 3i bar plus 1 by 2 minus I is equal to. First you write this as conjugate of this. What is the conjugate of this? Plus 3i. So we have to write minus 3i. Replace plus I minus. So minus I. Minus 3i plus 1 by 2 minus I. Now this is division form. I have told already the denominator is complex number means we have to rationalize the denominator. That means we have to bring this as a rational number. For that we have to multiply both numerator and denominator by its conjugate of the denominator. What is the conjugate of the denominator? 2 plus I. Why 2 plus I? Because here minus I. So we have to change this as plus I. So we have to multiply both numerator and denominator by its conjugate of the denominator. 2 plus I by here 2 plus I. Okay. Now 1 into 2 plus I, 2 plus I. See, look at this. This is in the form of a plus b into a minus b. Now what we have to write? A square plus b square. That is 2 square plus 1 square. 2 square plus 1 square, 5. So minus 3i plus 2 plus I by 5. See here, sum of the two numbers divided by one rational number. So we can write this as sum of the 2 by 5 plus I by 5. So here I am writing this as minus 3i plus 2 by 5 plus I by 5. Okay. See, next add like terms or group like terms. Here imaginary part, here I am grouping, here 2 by 5 real number. So 2 by 5 plus I by 5 minus 3i. Now this is fraction, no? Just you cross multiply. 5 into 3, 59, minus 59 plus I. So what is the difference? Minus 59 plus I minus 14i by 5. So 2 by 5 plus minus 14i by 5. We can write as 2 by 5 plus into minus minus 14i by 5. So Cartesian form of 3i bar plus 1 by 2i is 2 by 5 minus 14 by 5i. That's all. Okay. See, first you have write conjugate and you simplify this complex number and you will get the Cartesian form of the complex number. Okay. Next, the second problem. If z equal to x plus iy, find the following in Cartesian form. See, third Roman and problem is imaginary of 3z plus 4z bar minus 4i. Imaginary of 3z plus 4z bar minus 4i. First we have to simplify this complex number. Afterwards we have to write the imaginary part. Got it? Okay. What is the z? Z equal to x plus iy. Just you have to substitute in the place of z x plus iy. Okay. Now 3 times z. But 3 into x plus iy plus 4 into z bar. What is z bar? This is nothing but conjugate of a complex number. Conjugate of z. What is conjugate of z? X minus iy. So here 4 into z bar, 4 into x minus iy minus 4i. Next, fully simple concept only, just ordinary simplification. Okay. Now just you multiply the bracket. 3x plus 3 into iy. Next 4x. Next plus into minus minus 4iy. Here one term, just you write it as it is. Minus 4i. Here 4 terms. Just you add like terms, real part and imaginary part. Now 3x plus 4x, 7x. 3iy minus 4i, these two like terms. So if we subtract this, we get here, this is the greater number, no? Minus 4 minus 3, iy. Next minus 4i. 7x, just you take I outside, minus y minus 4. Now we'll get one real part plus I into. Okay, now this is in the form of x plus iy. Suppose if x plus iy means what is the imaginary part? Y. What is in the place of y here? Minus y minus 4. So imaginary of this complex number is minus y minus 4. Therefore, imaginary of 3z plus 4z bar minus 4i is equal to minus y minus 4. Okay children, homework for today's class is first Roman, first problem and second problem, and second Roman, two problems given, first one and second one, and third sum. See, this is nothing but z1 plus z2 the whole bar. First you have write as z1 bar plus z2 bar. Next you write as the conjugate and simplify, you get the answer. This is division form or quotient form. Just you multiply both numerator and denominator by conjugate of the denominator. 6 minus 2i by 6 minus 2i. Then ordinary multiplication of complex number, you will get the answer. Here z equal to x plus y. Find the following Cartesian form. Real of 1 by z. So first you have to find 1 by z. Afterwards we will get some complex number. From that you have to write real part. Here is the same. First you write the conjugate and you multiply with the I. Afterwards you find the real part of this. Okay. Next third sum. If z1 on complex number 2 minus I and z2 equal to minus 4 plus 3i. Find the inverse of z1 into z2 and z1 by z2. This is nothing. z1 z2 is nothing but multiplication of two complex number. Inverse means z1 z2 the whole power minus 1, that is 1 by z1 into z2. Okay, now z1 into z2 ordinary multiplication. Now quotient form, both multiply and numerator denominated by conjugate of the denominator. Similarly, you do this. Z1 by Z to the whole power minus 1. It comes Z2 by Z1. So do these three problems as homework. Remaining we'll see in the next class. Thank you.